You might not be done with it yet, but let's see how you're doing with it so far. So here we have hammers and saws. And we have to start out by expressing the number sold. Now again, we look to see if one is calculated from the other. And we look on here, 8 times as many hammers as saws. Which one sold more? Hammers sold more. Which one do we need to know first? The saws. So that's X saws. How many hammers would it be then? 8 times the number of saws, 8X. Now, then we need for the dollars. Remember, the dollar amount, the dollars sold is equal to the price times the number sold. So we've got the number sold here. We just need to add, combine the price with each of those. For hammers, it's $15 each. 15 times 8X. For saws, it is $10 each. That'll be 10 times X. So 15 times 8X is 120X. 10 times X is 10X. And we go on to our equation. We're going to have an equation of 120X, the amount of money from the hammers, plus 10X, the amount of money from the saws, equals our total of $2,990. And then combine 120X plus 10X is 130X equals 2,990. And then divide by 130. X equals 23. Does that look right? I don't have my calculator up here. Okay, perfect. So X is 23. We do have to look back and make sure we have solved the problem, answered the question. X is 23, that's the number of saws. Hammers are 8 times X. 8 times 23 is 184. So 184 hammers. Any questions? Well, we're in a little bit of review mode here. I'm going to have you do another problem similar to last week. Stacy sells chairs for $20 and desks for $50. Stacy sells 5 times as many chairs. Oops, let's do this. Stacy sells a total of oh boy, let's do 36 items for a total of $900. How many of each were sold? I'll give you a couple minutes to try that one and we'll go over it. Let's see how it's going. So here we have chairs and desks. We do need the number sold. And again, we need to look to see if one is calculated from the other. And this time it really isn't. There isn't one that's a certain percentage of the other. So it doesn't work out nice and neat like that, or a certain multiple of the other. But we do know a total of 36 items. So if I just pick one of them to be X, we'll let the number of desks be X. You might ask, why did I pick desks? It really doesn't matter. I could pick either one. The reason I picked desks is because that's the most expensive one. Those are $50 instead of $20. And I've done enough of these to know that you work with less negatives if you make X to be the more expensive one. But you'd get the correct answer either way. If X is the number of desks sold, and there's a total of 36 items, how many chairs had to be sold? Well, there's a total of 36. If I subtract the number of desks, what's left is the chairs, right? So 36 minus X is the number of chairs sold. My dollar amount, once again, is the price times the number sold. Chairs were $20. So it's 20 times 36 minus X. Desks are $50. So that's 50 times X. So I have 20 times 36 minus X plus 50X has to add up to my total of $900. 20 times 36 is 720. We see the parentheses. Of course, we have to do something there first. 20 times negative X. Negative 20X. We got to remember we've got the plus 50X there equals 900. Now remember, before we start to solve, we have to combine anything on either side that we can. And we have to make sure that the variable only appears once. Here we can combine on the left side the negative 20X and the positive 50X to make 30X. And it's positive, so I put a plus in front of it. So that's 720 plus 30X equals 900. And then subtract 720. We got 30X equals 900 minus 720 is 180. And then divide by 30. X equals 6. So we go back up here and make sure we answer the question. We're asked how many of each. Well, X equals 6. So that means there were 6 desks sold. Chairs are 36 minus X. So 36 minus 6 means there's 30 chairs sold. Anybody, show of hands, anybody have both of those correct? Okay. If we have time at the end of the hour, we will, at the end of the class, I should say, we'll come back and maybe do some more examples of those. There are quite a handful of word problems on the test, but I would say only one of each of these types. I mean, not going to put a lot of these more complex ones. The ones that'll be on the test for this time around will be simpler ones for the most part. But how to get everything into an equation? Yeah. And that's the tough part, is taking the words and putting it into a formula. Okay. I said, at the end of the class tonight, if we get time, we'll do some more examples. Okay, our main goal for tonight is to talk about percents. And to understand how percents work, you first have to understand the word percent. Percent is actually 2 words. Per, if you think of miles per hour or miles per gallon, dollars per hour, it means for each or out of. And cent. Yeah, cents in a dollar, years in a century, 100. So if I have 34%, that literally means 34 out of 100. In fact, it is that simple to turn a percent into a fraction. A percent is a shorthand way of writing, it's technically called a ratio, but it's a shorthand way of writing a fraction. We just leave that denominator of 100 off. Now, of course, if we were turning that into a fraction, we wouldn't leave it as 34 over 100 because both of those can be divided by 2. Good. That would reduce to 17 over 50. And it's that simple to turn them into a fraction. Now, of course, not every example is going to be quite that convenient. We might have 85%. What's that going to become as a fraction? 85 over 100. And of course, both of those can be reduced by 5. Good. 85 divided by 5 is 17. 100 divided by 5 is 20. So 17 over 20. We might run into something like 264%. A lot of people are tempted to do something different here, and I'll explain that in a second. But percent is a percent. It is always out of 100. 264% is 264 out of 100. Now, we can reduce that. We look at that and we realize, first of all, 100 goes into 260, can come out of 264 a couple of times. So let's do that first. It's usually easiest at this point. How many times does 100 go into 264? Twice, and how much is left over? 64, and of course, yeah, the denominator stays the same. It's 64 out of 100. Now, we can still reduce that 64 over 100. Both of them can be divided by 2, but they could also be divided by 4. 64 divided by 4 is 16. 100 divided by 4 is 25. Am I done? Still got to bring that 2 over. A lot of people forget that when they're reducing them. So that becomes 2 and 16/25. I can run into something like this. 56.25%. Turn that into a fraction, just like any other percent, it's 56.25 over 100. Now, we don't like leaving decimals within our fractions, so we're going to get rid of it. The easiest way to get rid of a decimal is to multiply by 10 or 100 or 1,000, or it just moves the decimal point over. Which one would we multiply by here? 100, perfect. We have 2 decimal places, so we'd multiply by 100. If it was only 1 decimal place, we'd multiply by 10. 3 decimal places, we'd multiply by 1,000. 2 decimal places, if we multiply by 100, it will move that decimal over. So 56.25 times 100 is 5,625. 100 times 100 is 10,000. Now that can be reduced. What can both of those be divided by? Careful. 5,000. Careful, 5,000 won't go in there. You've got the right idea. I know what you're thinking. 5 will go into them. No zeros. You're thinking the other way around. You're thinking if the 5625 was the denominator. We're trying to reduce them. Both of them could be divided by 5. There's actually bigger numbers that could both be divided by. But they can be divided by 5. Let's do that first and see what happens. So we get 1, 1, 2, 5 over 2,000. Now we see they both can still be divided by, they can both be divided by 5, but we can shoot for something bigger. How about 25? We divide by 25, we get, what, 45 over 80. They can both still be divided by 5. 45 divided by 5 is 9. 80 divided by 5 is 16. Comes out to be 9/16. From the very beginning here, we could have divided by 625 if you wanted to. If we divided by 625, 5,625 divided by 625 is 9. And 10,000 divided by 625 is 16. How about 36 2/3%? To turn that into a fraction, again, just like any other one, it's going to be 36 2/3 over 100. Now, we don't like having fractions within our fractions either, just like we don't like having decimals in our fractions. We have a couple of options here. I'm going to show you 2 of them. The first one I'm going to show you, I can take my 36 2/3 and my 100, and I can look at them and see what the denominators are within each piece. Now, obviously, the 100 is the denominator of the whole thing, but I'm going to look at the numerator and denominator separately. There's a fraction up here. What's the denominator in the fraction? 3. Down here, the denominator is technically just a 1, right? It's 100 or 100 over 1. So the least common denominator there would be a 3. So I can multiply both the numerator at the top and bottom of this fraction by 3. 100 times 3 is 300. 36 2/3 times 3 ends up being 110. I'll leave it up to you guys to multiply that out in your notes or on your own if you want to. Now that we have 110 over 300, we can reduce. Both of those end in 0, so they can be divided by 10. Gives us 11 over 30. That's one option. That's probably the quickest option, but it requires you to look at that and realize if you multiply by 3, the fractions disappear. Another option that might take a little more work, but is a little more obvious, is we can treat any fraction can be treated as a division problem. So we can treat 36 2/3 over 100 as 36 2/3 divided by 100. Now to make that work, we make 100 a fraction by putting it over 1. When we divide mixed numbers like 36 2/3, we turn them into improper fractions. 36 times 3 is 108, plus 2 is 110 thirds. Again, that's just converting 36 2/3 to an improper fraction. Remember, it's whole number times denominator added to the numerator, gives you the new numerator. Yeah, and when we divide fractions, we multiply by the reciprocal. So this is going to become times, the reciprocal of this is 1 over 100. I would cross cancel here. Both 110 and 100 can be divided by 10. 110 divided by 10 is 11. 100 divided by 10 is 10. 11 times 1 is 11. And 3 times 10 is 30. We get the same answer. The reason I say, now you might be looking at this saying, well, that was a lot of work to divide that out, and it was. But the reason I say it was more reliable is it didn't require you to find a common denominator or anything like that. And the other reason is, if you have the fraction calculator, that one will do it. You just do the 36, ABC 2, ABC 3, hit divide, 100, and your calculator will spit out 11/30. Any questions so far? Your turn to play. turn those percents into fractions. I will pause and give you guys a couple minutes. Let's take a peek and see how you're doing. So 435%. Remember, percent is always over 100. We can split that up. 100 goes into 435 4 times. And there's 35 left over. What can that be reduced by? 5. Good. 35 divided by 5 is 7. 100 divided by 5 is 20. And don't forget the 4. 4 and 7 20ths. 18 and 1/3%. Well, again, percent is always over 100. We need to get rid of that fraction somehow. I'm just going to do 18 and 1/3 divided by 100. 18 and 1/3 becomes 55 thirds. Divided by 100 becomes times 1 over 100. We're reduced by 5. Cross cancel the 5. 11 and 20. 11 times 1 is 11. 3 times 20 is 60. It's 11/60. Questions on that one? Finally, 37.5 is 37.5 over 100. To get rid of that decimal, there's only one decimal place, so we multiply by 10. 37.5 times 10 is 375. 100 times 10 is 1,000. Both of those can be divided by 25. Actually, there's something larger, but we'll worry about that in a minute. That ends up being, what, 15 over 40? You can still be divided by 5 because it's 3 over 8. How are we doing so far? Didn't like the bottom one? Yeah, the middle one is the one I think is the hardest one. The bottom one, if you have that fraction calculator, once you do the multiply by 10, you can just enter that in, 375 ABC 1000, hit equals, and it will reduce it for you. Just type it in as 375 ABC 1000, hit equals, and it will reduce it for you. And this one here, same way, like we said before, you do the 18 ABC1, ABC3, and divide it by 100, and it should reduce that one for you as well. Our next step, converting a percent into a decimal. We had 34%, which we said was 34 out of 100. Now, when we were converting to a fraction, we reduced it as a decimal. To get from a fraction to a decimal, we just divide it out. So to turn that into a decimal, it's 34 divided by 100. When we divide something by 100, what does it do to it? Moves the decimal point over 2 spots to the left. So that becomes 0.34. So 34% converted to a decimal is just 0.34. Since any percent, let's say I have 70%, is going to be out of 100, to convert it to a decimal, we are simply dividing by 100. And dividing by 100 always moves that decimal point 2 spots. So that becomes 0.7. If you put 0.70, that's fine as well. So to convert a percent into a decimal, the shortcut becomes just moving the decimal point. So if I have 42%, what's that going to become as a decimal? 0.42, good. 280%. What's that going to become as a decimal? 2.8. No percent. It's a decimal now. 7%. 0.07. Good. 3.2%. 0.032. Good. How about, this is the one I usually catch people on, 0.25%. There you go. 0.0025. Well, 1/4 is 0.25, right? That's still a percent. To convert it from a percent into a decimal, that's 0.25 over 100. So you divide out the 100, it moves the decimal point 2 more spots. The reason I bring that one up is because most people do get it wrong at first. They want to say it's just 0.25. But 0.25 would still be a percent. You're just changing it from a fractional percent to a decimal percent. One of the things I stress when I work with percents is something called benchmarks. And we'll talk about these a lot more in the second hour tonight. But one benchmark that we use a lot is 1%. 1% is a decimal is 0.01. Is 1/4% bigger or smaller than 1%? It's smaller than 1%. So the decimal form for 1/4% better be smaller than the decimal form for 1%. You okay over there? You got that dazed look. That one threw you for a loop? Let's do this. This is 3/8%, right? That's 3/8 of a percent. That is smaller than 1%. 1% is one whole thing. Not one whole thing. It's 100th. 1 out of 100 or 0.01. 3/8% is 3/8 out of 100. If you divide that out, 3/8 divided by 100, that divides out to be 0.00375. That's the decimal form of 3/8%. Yeah, you move it 2 spots because you're dividing by 100. So yeah, you can think of it as 3/8 is 0.375. Yes, a percent is always out of 100, always divided by 100. A percent, we said, is always out of 100. So 32% means 32 out of 100. A decimal is always out of 1. It's what's called a rate. And a rate is technically, it's a unit rate, is always per 1, for every 1. So that makes sense that the decimal form or the rate form would be 0.32. Because technically what that is that's 0.32 out of 1 for every 1. 32 out of every 100 is equivalent to 0.32 out of 1. Okay, so how about going the other direction? If I have a decimal, I have that rate, as we said, is the decimal form of a percent, and I want to convert it back into a percent. So I have 0.85 as a decimal. Convert that into a percent. We notice, well, we don't notice, we go through the process. A decimal is out of 1, and a percent is out of 100. To find that missing number, we can cross multiply and divide. There's two numbers that are diagonal to each other. That's the 0.85 and the 100. Your 0.85 times 100 is 85. And then there's the other number that's diagonal with our missing number. In this case, that's the 1. We divide by that. Divided by 1 is still going to be just 85. So what we have here is 85 out of 100, or 85%. Well, we can see there again, when we go from a decimal to a percent, we're going from something over 1 to something out of 100. And really all we're doing is just multiplying both the top and the bottom of that fraction by 100. 1 times 100 gives us 100. 0.85 times 100 is 85. That's 85%. So go ahead. Yep. Oh, here, let me show you what I was doing there. Let's do this. Let's just do like 0.35, right? I'm going to do this a slightly different way. Then we'll build up to what I did up here. So that really means out of 1. A percent is always out of 100. To convert that fraction, we just have to multiply both the numerator and denominator. What do I multiply 1 by to turn it into 100? 100. So I'm going to multiply the top by 100 as well. 0.35 times 100 is 35. Percent is always, yep. Nope, straight across here and here. If I multiply, remember in a fraction, whatever I multiply the numerator by, I have to multiply the denominator. If I take 3/4, if I multiply the denominator by 5, I have to multiply the numerator by 5, right? If I multiply the denominator by 100, I have to multiply the numerator by 100. Remember, percent is, you're overthinking it a little bit. Remember, a percent is always out of 100. So you know this denominator is going to have to be 100 if it's going to be a percent. So let's take another decimal. Let's take like 0.42 as a decimal. A decimal means out of 1. That's out of 1. If I want to convert it to a percent has to be out of 100, right? So this part that we have right here so far is just given. We're going from a decimal, which is out of 1, to a percent, which is out of 100. So now to make that conversion, we have to change 1 into 100. And we do that by times 100, right? So if I multiply the bottom number by 100, I have to do the same to the top. Where'd the 100 come from? Well, because that's what a percent is, always out of 100. Yeah. You could think of it that way. Yeah. That denominator is always going to be 100 because it's a percent. Okay. Yeah, it'll always be 100. Yeah. And since we're always going to be multiplying by 100 here because the percent is always out of 100, it's essentially just moving the decimal point 2 spots. So if I have 0.91, we move that decimal point 2 spots, that's 91%. If I have 2.7, what's that going to become as a percent? 270, very good. We move it 2 spots. I have to add a 0 in there. If I have 0.3, what's that become as a percent? 30%. If I have 0.076, what's that becomes a percent? 7.6%. Very good. It's always moving the decimal 2 spots. Multiply by 100. What if I have a fraction that I want to turn into a percent? I'm going to start out with one that we probably all know. 3/4 is what percent? 75%. Good. What if we didn't know that 3/4 was 75%? Well, there's a couple of things we could do. We could turn 3/4 into a decimal by doing 3 divided by 4, which is 0.75, and then turn the decimal into a percent, which we just did. You move the decimal over 2 spots, 75%. What's that? For a lot of people, that's the easiest if it's like 3/4, one that divides out to a nice even decimal. Another way we can think about it is 3/4 can be thought of as a ratio, 3 out of 4. Well, what's a percent always out of? 100. To find that missing value there, just like we did up above with the decimal, what do we have to multiply 4 by to turn it into 100? 25, right? So we have to multiply 3 by 25 as well. 3 times 25 is 75. 75 out of 100 is 75%. Well, that one works out just fine doing this because 4 goes into 100 nice and neatly. But what if it's not so nice and neatly? Like 5/8. That's 5 out of 8. How much would that be out of 100? Well, most people don't know off the top of their head what you multiply 8 by to get 100. If you don't know that, what you need to do to find that number is you're just going to do 100 divided by 8, right? Once you get that number, what are you going to do to it? Well, you're going to multiply here 100 times that, or 8 times that gives you 100. But you're also going to multiply the top by the same thing. If you look at this, what's happening is 5 times 100 divided by 8. To shorten this process, this is kind of where you were getting with that last example, kind of getting ahead of us just a little bit. If I look at here, what's the 5 getting multiplied by? Well, always this number down here. It's diagonal with the 5. That's what we call that a cross product. So you cross multiply 5 times 100, which is 500. The two numbers that are diagonal with each other get multiplied. The third number we divide by, the 8. 500 divided by 8 is 62.5. So 62.5 over 100 is 62.5%. We might have 2/7. If we want to turn that into a percent is out of 100. This one's really tough. We wouldn't be able to look at it and figure out what do you multiply 7 by to make 100. But we can use this shortcut, cross multiply and divide. To cross multiply, which two numbers get multiplied here? 2 times 100, those are the ones that are diagonal with each other. 2 times 100 is 200. And then we're going to divide by this, the final number, 7. 200 divided by 7 is 28.5714286 approximately, right? You'll believe me? I would have to tell you where to round that. If I tell you to round it to the nearest 100th percent, yeah, 100th is its 10th 100th, so we round it there. 28.5, does that stay 7 or go up to 8? Stays 7. Good. How do we know? The next digit was a 1. So less than 5, it stays 7. How are we feeling? Okay, it is the end of our first hour, so time for a break. Let's take 10 minutes. At 6:20, we will come back at 6:30. Okay, so we can convert percents from one form to another, to decimals, to fractions, and back to percents again. Let's look at the basic calculations with them. So what we're going to look at here first is just little sentence problems. Things like find 18% of 45. Now, the method I'm going to use here first is called the proportion method. And it looks a lot like what we were just doing when converting our fractions into a percent. So in the proportion method, we always start with the percent. Here, that's 18%. And 18% as a ratio or as a fraction is always 18 out of 100. Now, these two pieces of a fraction actually have very specific meanings. 100 is referred to as a base amount. A base amount is either the whole thing, the whole amount, or it can be thought of as a starting or initial amount. That is the amount, though, that the calculation is based off of. That's why it's called a base. The 18 is a piece or a portion. The portion is a piece of the base. So it's a small amount or a smaller amount out of the base, usually smaller. Sometimes it can be over 100%. But it's a portion or a piece of that base that we're focusing in on in this problem. So in this problem, we're focusing in on 18%, 18 out of all 100. So now in the problem, there's always two other values that go with those pieces of the percent. One is the whole amount that matches up with the base. It's what everything's being calculated out of. Now in a problem like this, that's easy to find because the word of gives it away. You can think of that as out of 45. That indicates the 45 goes on bottom. It matches up with 100, that base amount. 45 is the base amount. So the piece we're focusing in on is what goes up here. That's the number we're looking for in this problem. Now, exactly. This is a proportion with a missing number, so we cross multiply. 18 times 45 is, I believe, 810. Divided by 100 is 8.1. So 8.1 is 18% of 45. Now, there's a lot of different ways of wording pretty much the same problem here. Let's look at a similar problem worded a little bit differently. Let's look at blank is 125% of 60. So again, it's worded different, but we're still going to start out the same way. We have the percent, 125. The percent goes over 100. Now on the other side, we have two numbers to match up. One that we're given and one that's missing. If we look at this, blank is 125. That implies the blank goes with the 125. Also, the wording is of 60. If again, we look at that as out of 60, it implies the 60 goes on bottom. So we can see it's very similar to the problem up here. So we're going to cross multiply. 125 times 60 is 7,500. Divided by 100 is 75. Now you'll notice here that this piece or portion is bigger than the whole thing. Why is that? Well, it's because the percent is bigger than 100. Yeah. Well, not 750, it's 125%. It's just bigger than the original amount because 125 is bigger than 100. 100%, remember, is the whole thing. 125 means it's bigger than the whole thing. So when your percent is bigger than 100, the piece you're focusing on is bigger than the whole amount, bigger than that base amount. Nope, because that's the number we're looking for is 75. So it isn't really a fraction. It's set up in a fraction there, but it's a number in itself. Yeah. There are other ways to word problems like this. We might see 70% of 30 is blank. Worded very differently, but a very, very similar problem. 70% is 70 out of 100. 70% of 30, again, if we read that as out of 30, it implies the 30 goes where? On bottom. Yeah. 70% is blank, implies that blank goes with the 70. So now we cross multiply and divide again. 70 times 30 is 2100. Divided by 100 is 21. So 70% of 30 is 21. Now, does that make sense? Well, yes, 70%. 70 is smaller than 100. 21 is smaller than 30. That makes sense. We might have 42 is 60% of blank. This one's a slightly different type of problem. We're going to start out the same way. 42 or 60% is 60 out of 100. Now on the other side here we have 42 is 60%. That implies the 42 goes with the 60. It goes on top. Of blank, again, if we think of that as out of blank, that implies the missing number goes on bottom. Now we can see compared to up here, the numbers are in different spots, but the process is still the same. What two numbers are diagonal from each other? Yeah, the 100 and the 42. So those are the two we multiply. 100 times 42 is 4,200. And we divide by the 60. That gives us 70. So 42 is 60% of 70. We might have 25% of blank is 26. Again, we start with a percent. 25% is 25 out of 100. Of blank, once again, if we read that as out of blank, implies the missing number goes on bottom. 25% is 26, implies the 26 goes on top. Now, some of you may have been taught at some point a little thing of is over of. Does that sound like something you've heard? In a sentence, these simple word sentences like this, of blank, that's the number that goes on bottom, is 26, that's the number that goes on top. Now that's a little gimmick that only works for this type of simple problem. When we get into more complex word problems, that doesn't always work out. So I don't want you to get too dependent on that. But if you get really stumped on these simple problems, that does work. So now you can see it's the same type of problem we had up here. We'll cross multiply. 100 times 26 is 2,600. And divide by 25. Gives us 104. So 25% of 104 is 26. we can have a little bit different problem yet. 42 is blank percent of 70. Now, we've said in this proportion method, we always start with the percent. But in this problem, we don't have the percent. Doesn't matter. We're still going to start with the percent. Blank percent is blank out of 100. So that top number above the 100 is going to stay blank until we solve. So the other two numbers go on the other side. 42 is blank. That implies the 42 goes with our missing percent. It goes on top. Of 70, again, if we read that as out of 70, it implies the 70 goes on bottom. Now, once again, we see the numbers are in different spots again, but it's still the same process. The two numbers that are diagonal get multiplied. Which ones are those? Yeah, 100 times 42, which will be 4,200. And the one that's on the other diagonal by itself, we divide by. We divide by the 70, which will give us 60. So that is 60%. Or we might have blank percent of 80 is 14. So if we look at this blank percent, we're missing the percent again. That's blank over 100. Think of out of 80. What's the 80 on bottom? 14 goes on top. We will cross multiply and divide. 100 times 14 is 1,400. Divide by 80 is 17.5. So it's 17.5% of 80 is 14. So this is the proportion method. What I really like about the proportion method is once you get the numbers in there and in the right location, the calculation is always the same. You find the two numbers that are diagonal, you multiply them. You divide by the third number. It's always cross, multiply, and divide. There is another method that's been commonly taught for fractions, or for percents, and that is something called the rate method. Of our percents. And the rate method uses a rate. Remember, a rate is the decimal form of a percent. So what we would do for that is we would take the 18%, convert that into a decimal. That is 0.18. So for this problem here, we would take our number, the 45, and we would multiply it by that rate of 0.18. It would give us 8.1. That actually seems relatively simple, almost easier than this proportion. Even this one down here, we have 125%. As a decimal, that's 1.25. We would take our number there, 60, times 1.25, which would give us 75, which is our answer. Again, that seems quicker and simpler. And for these two problems, it was quicker and simpler. Even the third one here, it would be simpler. 70% as a decimal is 0.7. You take 30 times 0.7 is 21. The catch is we get to problems like this fourth one. The percent is 60%. As a decimal, that's 0.6. But we would not multiply by 0.6 here. We would have to take the 42 and divide by 0.6 to get 70. The reason is up here, what we were given was the whole amount, the number that matches up with 100%. That's the number that the percent is based off of. So we just multiply by that rate. Down here, what we are given, 42, is that portion, that piece that we're focusing in on. So to get back to that base amount, we have to divide. Same with this fifth one here. 25% is 0.25 as a decimal. It would actually be 26 divided by 0.25 to give us the 104. So if you're going to use the rate method, you have to be able to figure out, am I going to have to multiply by the rate or divide by the rate? In fact, there's even a third type you run into here with this one where we're missing the percent. We don't have the percent here, so what we end up doing is taking that portion, the 42, and dividing by that base amount, the 70, gives us 0.6. That is a rate that we convert into a percent of 60%. There's other reasons why I prefer this proportion method. I mean, the proportion method, like I said, is always the same calculation, cross multiply and divide. When we get into some of our word problems, we'll see that that proportion actually helps us match up the numbers in the word problems. The rate method is quicker if you know what operation to do with it. The time that the rate method gets used a lot, and it does get used a lot, is when we know we are given the base amount and we want the portion. Because that portion is going to be found as just taking that base amount times that rate, that decimal form of the percent. When we calculate commissions, we calculate simple interest, that happens often enough that, yeah, we will use that. If you were in construction or other places where you're doing materials bids, even like carpet, painting, stuff like that, where you have a percentage for waste, you would use a rate method to figure in that waste percent because you have the base amount, you have the whole amount, and you're looking for a portion. So you just very quickly multiply by that rate. Let's look at some word problems to demonstrate why I say that proportion method helps us match up numbers. For example, we might have PMD Corporation estimates gross profits as 15% of net monthly sales. What were the net sales for a month when gross profits are estimated at, oh, let's see here. $48,150. So, just like in our simple problems up above, we have a percent here. That percent is 15%. That's 15 over 100. Remember that 15 represents a piece that we're zeroing in on. The 100 represents a larger base amount. That base amount is what the piece is coming out of. So if we look in the problem here, we have gross profits and we have net monthly sales. Which one is that bigger piece, that base amount? Careful. You always say net smaller than gross, but we're talking about two different things here. Is all of your net sales going to be profit? No, some of your net sales go to cost, go to labor. The gross profit is the smaller of those numbers. It is 15% out of the net monthly sales. That 100%, that base amount, is the net monthly sales. Kind of like in those word problems we did last week, we need to know the net monthly sales to calculate our estimate of gross profits. We are basing the calculation of gross profits off of the net monthly sales. So the net monthly sales are the base. The 15 represents the gross profits. So now on the other side of this, the 48,150, does that represent the estimate of gross profits, or does that represent the net sales? What are the net sales? That means we are looking for the net sales, right? For a month where gross profits are estimated at 48,150. So that 48,150 is representing gross profits, the estimate of gross profits. In a problem like this, it's real easy to assume, since that 48,150 is a large number, that it has to go on bottom. Here it does not. So we have 100 times 48,150 divided by, my calculator still didn't come up. Do this again. Something still, you're off by a decimal point there somewhere. So we have 48,150 times 100 divided by 50. 321,000. So the gross profit, or the net sales for that month had to be 321,000 if the estimate of gross profits was 48,150. Yep. Okay. Now, in business, most of what we use for percents are going to be margins, profit margins, markups, investments, return on investment, stuff like that. So let's take a look at some of those applications. Let's say that Pete receives a 9% discount. How much does Pete save on items listed for $720? List price would be the full amount, and we're looking for the amount saved. So our percent here is the 9%. It's going to be 9 over 100. What does the 9 represent? The discount. The 100, the base amount, well, what do we use to calculate the amount of the discount? That's the full price, right? Whatever the marked price or the full price is, you find that 9%, and that's what you're going to subtract from it. In this case, that full price is the list price. The full or the list price. So on the other side, where does the 720 go? That's the list price. It goes on bottom. And so we will do 9 times 720 divided by 100, which is what, $64.80? So $64.80 is the amount of the discount, the amount saved. I'm going to have you guys try one in your notes. On items listed for $350, Alex saves $53. What is Alex's percent discount? What percent discount did Alex receive? I'll give you a minute, see what you got. So in this problem, we don't have the percent. So it's blank over 100. But this is a discount problem, so that percent does represent the discount. The 100 is representing the base amount, which in this case would be the list price, which is, you are exactly correct, the $350. That's the list price. The 53 then represents the discount. That goes on top. We shall cross multiply and divide 100 times 53 divided by 350. We get 15.142857,142. Yeah, 15.14%, we'll call it. So 15.14% discount. How many of you had that right? Show of hands. Good deal. You'll notice there's a pattern here, by the way. In every one of these problems, we have different amounts. So far, we've only been looking at 2 amounts per problem. Like here, we have the discount and we have the list price. And each of those amounts are described by 2 numbers. They're described by a percent. We've got the 15.14% here. But the 100 is also a percent. 100% means the whole thing, or base amount. And then there's another number. In this case, it's dollars. The one side will always be percents. The other side won't always necessarily be dollars. For example, Tommy's Bakery produces 800 donuts each day. Tommy expects 15% to spoil without being sold. How many donuts? I gotta stop saying the word donuts. It's making me hungry. I'm spelling that horribly too, I know. How many donuts will spoil? I'm gonna give you a second. Try that one. Okay, so we have the 15%. That's 15 out of 100. The 15 represents the ones that spoil. 100% represents all the ones that are made. On the other side, 800, is that the number that spoiled or the number that are made? Number that are made. We're looking for how many will spoil. Cross multiply. 15 times 800 divided by 100 is 120. Not around me would that many spoil. So not around me would we have that many spoiling. Okay, well, let's look at another example. After 15% spoil, Tommy has 340 donuts to sell. How many spoiled? I'm going to give you guys a couple minutes or a minute or so to look at that, to work on that, then we'll talk. So for this one, we have the 15%, 15 over 100. The 15 represents the spoiled. 100 represents all, everything that's been made. On the other side, we have two things. We have a number we're given and a number we're looking for. But we are looking for how many spoil. So this is the number we're looking for. That's good. Now, a lot of people will blindly put the 340 on bottom. There's a problem there. Does 340 represent all donuts made? It's the ones that sell. It's the ones after the spoilage. So that does not represent the 100%. In a problem like this, there is a third percent that's not shown, but it's always there. We have all the donuts that have been made. From those, we're going to subtract the ones that spoil. And that's going to give us the ones that are available to sell. And like we mentioned earlier, in a percent problem, every item is described by two numbers. They're described by a percent, and then they're described by another number. In this case, the number of donuts. Well, on our percent side, we have the 15% that spoil. And of course, this number here is always our base amount. That's our 100%. We subtract the spoiled from the ones that were made, and we'll do that with the percents as well. 100% minus 15 is 85%. The ones that are sold are represented by 85%. The 340 here is the number that are sold. That goes here. What are we looking for? How many that's spoiled, right? So that would be this number right there. So in this situation, we need only two of these lines in the table. We need the line that has both numbers. One of these items has both the percent and the number of donuts. In this case, that's the number of donuts sold, or the donuts that are sold. And then we also need the line that has the item we're looking for. We're looking for the number spoiled, so we need that line. What that's telling us is we don't need the top line. How do I find that missing number? Well, I can actually use this table just like a proportion. Within the table, I can cross multiply and divide. Now, I'm going to ignore this negative here. That's not really there. So I can cross multiply and divide, and I can do 15 times 340 divided by 85. Comes out to be 60. 60 of those donuts sold left us with 340 that were available, or sorry, 60 of them spoiled left us with 340 that were available to be sold. This is a percent decrease problem where we had an original amount, it was reduced by another amount to give us the final thing. It was reduced by a percent to give us the final thing. These are the tricky ones. So let's look at a discount problem similar to that. So Sam receives an 8% discount. How much does Sam pay for items if Sam saves $136? So now again, it doesn't matter what words we use to describe it, as long as we know what we're describing. There is a price here, an original price, that I'm going to call full price. Does Sam pay full price? No, because Sam gets a discount. So from that full price, we subtract a discount. Once we subtract, that gives us the amount paid. So if we look at those items, again, the goal is to describe each of those items in two different ways. One way as a percent, the other way, in this case, is back to being a dollar amount. We have the $136. What does that describe? How much Sam saves. That's the discount. So the amount of the discount is $136. The 8% represents, that's also the discount, right? On the percent side, there's an 8% discount. It kind of is, yeah. Now, there's 1% that we always have, and that is the 100%, which goes where? The full price. The amount paid down here then is found by doing what? Full price minus discount. So 100 minus 8 is 92. What are we looking for? Are we looking for the full price or are we looking for the amount paid? How much does Sam pay? We're looking for this number here. So we don't need that top row. So now we can cross multiply and divide here. 92 times 136 divided by 8. So it's $1,564 is what Sam paid. Let's look at the other side of this. After 6% tax, Peyton pays $477. How much was the tax? I'm going to give you guys a second, see what you can figure out on that one. We'll talk about it in a minute. So if we look at this, we have that list price or the full price, however you want to look at it. But this time we're not subtracting a discount, we are adding a tax, which will give us the amount paid. So now we still have percents on one side, and it's dollars again on the other side. The 477, what's that? That's the amount paid, 477. That's dollars, so it's going to go on the dollar side for the amount paid. What do we know on the percent side? 6% goes with the tax. What else do we know on the percent side? Well, we always know the 100%. So now then the amount paid has to be 100 plus 6, because we're add the tax. That's 106%. What are we looking to find here? This number here? This one? Here? Yep, well, we got to look at what are we looking for? How much was the tax? We're looking for this number here. So that means we don't need the top row. Yeah, so it's 6 times 477 divided by the 106. The top number is determined by what over here, what we don't need on the other side. We didn't need this one, so we don't use the 100. I'll show you an example in a second where we cross out the middle row, though. So 6 times 477 divided by 106, what do we get, 27? After a 12% surcharge, Phil pays $840. What was the price without the surcharge? So here again, we have the full price or the list price, whatever you want to call it. I'm going to call it list price. You can call it the price before the surcharge or just price before or whatever. To that, we are adding that surcharge, that fee. And of course, that gives us the amount paid. Again, we have percents and we have dollars. The $840 represents the amount paid. 12%, of course, goes on the percent side for the surcharge. And of course, there's always that lurking 100%. Is this number down here 88 or 112? 112. This is a case where we add that percent, not subtract. What are we looking for? The list price, the price without the surcharge. We're looking for this number here. Now we have to keep the bottom row because we have both numbers. We have to keep the top row because that's the one we're looking for. So it's the middle row that we don't need. So now it's the 100 times 840 divided by 112. Get $750. Does that look right? Or did I screw that up? That's wrong, isn't it? 100 times 840 divided by 112. It is 750. Okay, it is 7:21, so it's time for a second break. Let's do 10 minutes. We'll be back here at 7:31. So if looking at these, you can see when we have a percent increase or decrease problem, many times the percent that's given in the problem, in this case, the 12%, is not really the percent that we're using. It's either going to be 100 plus that percent in a case like this, or in the case of the discounts or the decreases, 100 minus that percent. So you have to be very careful with those to check on. A similar problem might be Sam received a pay raise from $14.50 per hour to $17.40 per hour. What percent raise did Sam receive? So here's a case where we have an increase. We have the before, the pay before. To that, we're going to add a raise, and we're going to get the pay after. Now, again, these words here don't matter. It's what they represent. You might choose different words to describe them. It's the concepts that they represent that matter. So again, they're going to be described by percents, and most of what we do is going to be described by dollars on the other side. $14.50, where does that go? That's the pay before. But we also have the $17.40. Where does that go? The pay after. Now it looks like we don't have any percents in this problem, but we do have one. Can you tell me what it is? It's always the 100%. We always know that 100% matches up with something. Remember, I said 100% is that base amount or the initial amount. That's the pay before. So now as we look at this, it looks like we're trying to find, of course, the percent of the raise. This number here. For the pay before, we have both the percent and the dollar amount. So we're going to keep that row. However, we're looking for the raise, so we have to keep that row, but we don't know the number on the other side. But we can find it. That relationship is very consistent. We're adding this number plus this number has to equal this one. What do we add to $17.50 to get 17, or what do we add to $14.50 to get $17.40? Well, we work it backwards. We can just subtract. 1740 minus 1450 is 290. So this is $2.90. So we need the top row because we have both numbers. We need that middle row, the raise, because that's what we're looking for. We don't need the bottom row. What are we going to multiply here? 100 times 290, so it's $290. And then we're going to divide by 1450, which is going to be 20. Yeah. Now that's a percent. So that is a 20% raise. Don't expect to see too many of those in your lifetime, by the way. I have seen like 12, 15% raises when you go from like a probationary or trial period to your permanent. Other than that, you don't see too many raises above, four or five, maybe 8 in a really prosperous year. Really? Same position, or oh, they needed you there? Sure. Oh, sure. When I worked in engineering, a lot of people would leave, go to another place, come back like 8 months later. And you had people that would do that. They would let's say, for example, your base salary was like $40,000. They would leave somewhere else and they'd get offered more money to go somewhere else. Then they would get offered more money to come back. So let's say the person that had been there for the whole year might have gone from 40,000 to 40,500. That person who left and came back has gone from 40,000 to like 48,000, just because of jumping around. So in a lot of industries, that's how you get a raise, is you get a job somewhere else and they give you a raise, or you get offered a job somewhere else and you go back to your company and say, hey, I am leaving unless you can match this or beat it. And some companies will do it, some companies won't. Yours won't? Yeah, sure. Yeah, there's always a risk there of them saying, okay, bye, see you. Okay. Yeah. Remember, next week is test one. Some information you should know about test one. There is no time limit. But it must be completed unless other arrangements are made on February 14th. It must be done in one sitting. Now I'm going to describe that. That doesn't mean you can't get up and go to the bathroom or go have a smoke. You can take breaks. But that does mean you can't start in the morning, work for 2 hours, and go do something else for 4 or 5 hours and come back and finish it. A reasonable break, 15, 20 minutes, and come back and go back to work. Unless other arrangements are made. If there's some reason where you absolutely cannot take it next Wednesday, make that arrangement ahead of time so that we have it set up. Or if there's other accommodations or other conditions where you have a good reason, medical or otherwise, where you have to take that break, that's fine. But I do require it to be completed in the same day. I'll get back to that. The time frame I can give you, most students do complete it. This first test, the average is about 1.5 hours. But I do have students that will be here for 2.5 or 3 hours. I will tell you this, in the history of this class, I've been teaching this class. I didn't teach it my first 2 years here. I've been teaching this class now for 16 years, at least one section a semester. Only maybe once or twice in that whole time has the person who has done first had the highest score in the class. So take your time, there's no rush. I gotta grab the test and look at that, and I'll get that one to you in just a second. For those of you at the far sites, for Hayward and New Richmond and Ashland and Superior and Ladysmith, you guys can take it any time during the day that you're free. I will have it to your location by the end of the day Tuesday. So you can either go to your, depending on your location, some locations have a separate ITV office. Many of the locations, that just go to the library desk and they'll have it. You can just pick up your test there. They will, they'll make sure that you know what you're allowed to do and stuff like that, and just take it anytime during the day. But again, it has to be done in one sitting. You can't start in the morning and come back in the afternoon. You can't walk off with it and bring it back later. You have to do it in their controlled environment. Here in Rice Lake, I am in this room starting at 7:30 in the morning. So come on in. Anytime, if there's a class in here, just walk in. And the only exception to that is from 11:36 to 12:22. I am in an ITV to the high school, to high schools. I can't be disturbed during that time. So if you see the screen, the monitor on up there, don't come in. Otherwise, if there's a class in here and the monitor is not on, come on in. I'll get you set up with a test. Yep. Stop on in. Yep. I can let you come back and finish up as long as it's a class that you have to. I don't want you to like go home for like 3 hours and sit there and study or call friends and say, how would you do that? You know, if you're going to another class, it's obviously you're not going to be able to sit there and study while you're in another class. Oh no, you can stay in here and work. I can't like get up and go dig out the test for you at 11:36. Yeah, if you're still working at 11:36, you can sit in the corner and quietly work. I just can't answer any questions or dig out the tests. Um, what'll happen is yeah, from 1:30 to 5:30, I am not scheduled to be here at all. But I will, if I leave the room, I will leave a pile of tests on the table there. So just grab one and sit down and work. Just come in and work. Yep. You may use your books, your notes, and your calculators on the whole thing. My philosophy is never in life will you be on the job and your boss gives you something to do and you better not look anything up. My concern is that you can solve the problems, not that you have everything memorized and don't use any resources. In fact, I kind of want you to learn how to use resources. Now, I will tell you this, if you don't study and you come in here cold and expect to figure the whole thing out when you're taking the test, you're going to be here for a while. Laptop is fine, so you can access my math lab. You can do my math lab, just no internet searches. No Google searches or anything like that. So now the test itself. This test is 40 questions. How is that broken down? The biggest question is usually, how many word problems? You're not going to like this number. There are 13 word problems. Everything from the start of the class till now. In the book it is, yeah. In the book it's usually chapters 2, 3, 4, and 6 or something like that. If you look in your book, there's chapters missing. So things you'll need to know. Of course, you'll need to be able to work with fractions and decimals. By the way, fractions and decimals, it is just fine if you use your calculator. As long as you know how to enter it. There's a reason why I recommended that fraction calculator at the beginning of the year, because it saves a lot of time. You'll need to be able to solve proportions. Remember a proportion? That's kind of like what we worked on. Well, it is what we worked on tonight, where you have two fractions that are equal to each other. Like you might have 5/12 equals 25 over x. How do you find x? Cross multiply and divide. You will need to remember order of operations. This discussion was cut very short in class because we ran out of time on the first week. We did just a little bit of it, but there are I did put a supplemental video out on Blackboard for you if you need more work with it. But if you recall, order of operations is when we have a problem like, oh, let's see. Something like this. Order of operations says we have 4 levels we have to go through. First level is enclosing symbols. That's the parentheses. We got to do what's in there first. Inside there, we still have order of operations. Now, there's no other enclosing symbols. There's no exponents, no powers or roots. We do have multiplication or division. 2 times 7, which is 14. So we replace 2 times 7 with 14. Notice the rest of the problem has not changed. Now we're still working inside the parentheses. 8 minus 14 is -6. Now we've reduced what's in the parentheses to a single number. If it were positive, I could take the parentheses out, but I'm going to leave them there because it's a negative number. But I'll notice the 3 was here in front of the parentheses with no operation. What do I have to put in there? Multiplication. That is 3 times -6. And the 9 plus that still stays there. Now we're done with the parentheses. We move on to the rest of the problem. No other enclosing symbols. No exponents, no powers or roots. So we've got 3 times -6, which is -18. I'm always in the habit of leaving negatives inside parentheses just so I avoid mistakes. Now I have 9 plus a -18, which is -9. Nope, because that 9 it's a plus there, not times. You'd only work with it, you only do it if it's multiplication. You can do it mentally or if you enter your calculator properly. If you know how to enter in your calculator, it comes out in one step. Yeah. No, I'm not going to get picky about that. Now, a little bit trickier type of problem might look like this. So looking at this one, we have this across here. It's called the fraction bar. It means divide, but it's also one of the enclosing symbols. It separates one part of the problem from the rest. So that means we have to do everything on top here first, then do everything on bottom, and then we divide. So it's almost like doing 2 separate problems and then dividing those results. So let's do the top first. I'm going to write it over here so we have room to work on it. Are there any other enclosing symbols there? No. Any exponents? No. No powers or roots. Multiplication or division? Yes. 4 times 7 is 28. So replace the 4 times 7 with 28. Notice everything else stays the same. All that's left is addition and subtraction. So we go left to right. 5 plus 28, 33. And then we have 33 plus 3, which is 36. So the top is equal to 36. On bottom, what do we do first? Any other enclosing? There we go. There's no enclosing symbols, no powers or roots. We've got multiplication and division. We go left to right. 3 times 9 is 27. Everything else stays the same for now. We have then the 22 divided by 2, which is 11. And then 27 minus 11 is 16. So the bottom is 16. 36 over 16. 16 goes into 36 twice with 4/16 left over. 4/16 reduces to 1/4. So 2 1/4. Looking familiar? Okay. You need to be able to solve equations. And you may see such fun problems as things like this. Okay, let's make sure I've got this right. Such fun problems as that one. Now remember, there are 3 steps we go through. First one is we combine on each side. So is there anything on the left side over here that we can combine? Left side of the equal sign. Yeah, there's a lot of stuff we can do, isn't there? Combine or simplify. Yep, we do the parentheses. Nothing to do in the parentheses, so we have to distribute. 3 times 5x, 15x. 3 times -7, -21. Nothing to do in this parentheses either, so we have to distribute. Now we have to be careful. What are we multiplying by? -2. Good. -2 times 3x is -6x. -2 times -5. +10. Okay, so we've got 15x and -6x that we can combine to make 9x. -21 and +10 make -11. On the right side, is there anything we can combine? No. That's just 3x plus 17. The second thing we need to do is get the variable on one side. Is there a variable on each side down here right now? Yes. We can't work with that. We have to get rid of it before we start to solve. We get rid of the smaller one, which is the 3x. We get rid of it by subtracting. That's gone, leaves us with 17 over here. We have to take 3x off the other side. Where do we take it from? The 9x. 9x minus 3x is 6x. We still have the -11. Now we are ready to go ahead and do step 3, which is the solve. Remember, solve means you take it apart. This was built, x was multiplied by 6, and then 11 was subtracted. We take it apart by adding 11. 6x equals 28. And then dividing by 6. X is 4 2/3. How did I get 4 2/3? Well, this is 28 divided by 6. Notice that looks like a fraction. I can treat it like a fraction. 6 goes into 28 4 times with 4 left over. 4/6 reduces to 2/3. Any questions there? All right, go back. Let's see. You also need to do your percents like we did tonight. Going from a percent to a fraction, back to a percent to a decimal, back to a percent. Solving the basic percent problems, blank is blank percent of blank. Obviously, I'm going to give you 2 out of the 3 numbers. You got to find the third one. And then, of course, the word problems like we did. Now, the word problems with percents are the ones that tend to give people trouble. Remember, write them out and label them. Some of you didn't like that little table I did because you don't like having all that extra clutter there. But even if you don't do the table, label them. If I have, something like Sam pays 24% in income tax. What is Sam's take-home pay for a week where Sam's gross pay is $650? In a problem like this, if we label it, it saves us a lot of trouble. 24%, of course, is 24 out of 100. The 24 represents the income tax. The 100, the base amount, well, what is your tax based off of? It's calculated as a portion of the gross pay. So on the other side here, the $650 represents the gross pay that goes on bottom. This number up here represents the income tax. Are we looking for the amount of the income tax here? So that's not what we're asked to find, is it? If we know the amount of income tax, can we find what we're asked to get here? Can we use that? Well, let's take a look. 24 times 650 divided by 100 is going to be 156. That's the amount of the tax. If we know that the tax is $156, can we use that to find the take-home pay? Yeah, 650 minus 156. That's going to give us $494 take-home pay. So labeling, these labels help us avoid calculating something and what we find is not what we're looking for. They make sure that we're answering the question. Just like that table we did for our word problems for labeling stuff, this labeling in our percents is important to make sure we are actually answering the question that is being asked. Now, this question could have been answered with that chart thing too. We could have done gross pay minus tax equals take home. Percents and dollars. Gross pay was 650. Tax 24%. Of course, the base is 100. Subtract, this is 76%. We find the take home, we're using the 76%. 76 times 650 divided by 100 is 494. It's just like we were doing a half hour ago. Other types of word problems other than percents, we will see, like we said, the sales, Tim sells 4 times as many, blah, 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 that type of problem, like the problems we did to start the class. Or we might have, 25 items for a total of $920. How many of each type of item? Again, like we did at the beginning of the class tonight. And then some of our problem solvings with formulas, certain formulas that we've talked about. One might be distance traveled equals their speed times the time that they travel. One formula specific for business. Interest equals principal times rate times time. A little side note on this one, by the way. Remember, your interest is the dollar amount of interest earned. P, the principal, is the starting amount. R, the rate, that is the decimal form of a percent. And time is always in years. So if I give you that, you're given a problem where the time is 2 months, you have to make sure you express that as 2/12 of a year. Any questions? Okay, so remember, there is still a new quiz. I guess quiz 2. That was actually open, I think, at 4 o'clock today. That is due tomorrow. That'll be Thursday at 11:59 p.m. So you still have to do that quiz. And there will still be a new homework. That's homework 3. It'll be due next Wednesday. And like I said, next Wednesday, anytime during the day that you can get to in the far sites, either the ITV office or the library desk, to get your test, you can do it anytime during the day next week, Wednesday. The big advantage of doing it in class, of course, is you'll have me here to answer questions. For those of you in Rice Lake, by the way, if you do it outside of class time, in fairness to those at the far sites, I will only answer questions from 5:30 to 8:30. Unless it's a clarifying of what is this, what's this word mean, or if there's a typo or something like that, I will clarify. The typos, if there's a typo, I will help you. But I would say other questions about, what does this mean or something like that, I won't answer, except for between 5:30 to 8:30. Okay, you guys have any questions? Okay, you guys have suffered enough. Have a good night, and we will see you.